Picture this. You walk into any drag strip, time attack event, or drift competition in 2024, and there's one sound that dominates everything else. That angry, high-pitched scream hitting 9,000 RPM, followed by the whoosh of a turbo big enough to suck in small children. It's coming from a 20-year-old four-cylinder that was originally designed for economy cars. An engine so dominant that it single-handedly killed the aftermarket for every other import motor. This is the story of how Honda accidentally created the most overpowered four-cylinder platform in history, and why the K20 and K24 became the only swap that matters. It's 2001. The Fast and Furious just hit theaters. Every kid with a Civic is slapping a cold air intake on their D-Series and calling it Built. The B-Series VTEC engines are kings of the import world, B16s, B18s, the legendary B18C Type R. These engines defined Honda performance for a decade. They were light, rev-happy, and responded to modifications like nothing else. Builders were squeezing 300, 400, even 500 horsepower from these aluminum masterpieces. The aftermarket was massive. Everything from pistons to camshafts to complete turbo kits flooded the market. If you wanted to go fast in a Honda, you needed a B-Series, period. But Honda's engineers in Japan were already working on something that would make their own B-Series obsolete. Not because they wanted to, because they had to. See, emission regulations were getting brutal. The B-Series, for all its glory, was fundamentally a 1980s design that had been refined to its absolute limit. Honda needed something completely new, something that could meet stricter emissions, deliver better fuel economy, make more power, and still maintain that Honda reliability that kept people coming back. The development team got an almost unlimited budget and a simple mandate: create the four-cylinder engine for the next 20 years. What they built changed everything. The K-Series was a clean-sheet design that threw out every limitation of the B-Series. Where the B had a cast-iron block, the K went full aluminum with a deep-skirt design for rigidity. The old belt-driven cams? Gone. Replaced with a maintenance-free chain drive system. The B-Series head flowed well, but the K-Series head was something else entirely. Honda's engineers spent thousands of hours in flow bench testing, creating ports that looked more like something from a NASCAR engine than an economy car. The intake ports were massive, almost perfectly straight, with a cross-sectional area that grew progressively toward the valve. The exhaust ports were equally impressive, with a smooth radius that maintained velocity while minimizing turbulence. But here's where it gets interesting. The K20 launched with 200 horsepower in the RSX Type S, from 2 liters, naturally aspirated, on 91-octane pump gas. The compression ratio was 11.0.1, higher than most race engines from just a decade earlier. The red line? 8,000 RPM from the factory, with fuel cut at 8,200, but those numbers only tell part of the story. Honda integrated their VTEC variable valve timing with a new technology called VTC, Variable Timing Control. While VTEC switched between cam profiles for low-end torque and high-end power, VTC continuously adjusted cam phasing up to 50 degrees. The result was an engine that pulled hard from 2,000 RPM all the way to redline. No dead spots. No waiting for VTEC to kick in. Just relentless linear power delivery that felt more like a small V8 than a four-cylinder. The K20 used a square bore and stroke, 86 km by 86 km, optimized for high RPM operation. But Honda wasn't satisfied with just one variant. They developed the K24 with the same 86 mm bore, but stroked out to 99 mm, displacing 2.4 liters. This long-stroke design prioritized torque over peak RPM, making 160 pound-feet at just 4,500 RPM. In a 2,800-pound Accord, it felt genuinely quick. Now here's the kicker. Every K-Series engine used the same architecture, same bolt patterns, same head design, same bottom-end configuration. This meant you could take a K24 bottom end with its massive stroke and torque, bolt on a K20 cylinder head with its superior flow and high RPM capability, and create what the community calls a K24 K20 Frankenstein. Stock parts, no machine work. Just unbolt, swap, bolt together. The result? 2.4 liters of displacement with the breathing capability to rev to 8,500 RPM. We're talking 250 wheel horsepower, naturally aspirated, on stock internals with factory reliability. But that was just the beginning. The aftermarket discovered something incredible about these engines. The stock internals were overbuilt to a degree that seemed impossible. The forged steel connecting rods were shot-peened and sized to tolerances typically reserved for Formula One. The cast aluminum pistons used a high silicon alloy that could handle temperatures that would melt conventional pistons. The crankshaft was forged steel, not cast iron like most production engines, with journal sizes that belonged on a diesel truck. Builders started adding turbos, small ones at first, 300 horsepower on 8 psi, then bigger. 400 horsepower on 12 psi, then they got brave. 500 horsepower on 18 psi, all on completely stock internals. The engine didn't care. It just made power and asked for more. The tuning community went insane. Honda cracked the ECU, K-Tuner followed. Suddenly you could reprogram everything. VTEC engagement, cam timing, rev limits, fuel maps. A laptop and a few hours of dyno time could add 30 horsepower to a stock engine without turning a single wrench. Boost it? The ECU handled it. Nitrous? No problem. E85? The fuel system could flow enough with just bigger injectors. Let that sink in for a moment. While Nissan SR20 builders were upgrading internals at 350 horsepower, while Toyota 2JZ guys were swapping rods at 500, while even Mitsubishi 4G63 builders were reaching limits, K-Series engines were taking 500 horsepower daily, driven with nothing but bolt-ons. The stock block has been proven to 1,000 horsepower, 1,000, from a Honda economy car engine. The transmission options were equally overbuilt. The 6-speed from the TSX and Type S could handle 400 pound-feet without breaking a sweat. Gear ratios were perfectly spaced for the K's power band. First through third kept you in VTEC during acceleration. Fourth through sixth were tall enough for highway cruising at reasonable RPM. The limited slip differential from the Type S bolted right into any K-Series transmission housing. But the real genius wasn't just the strength, it was the modularity. Want more compression? K20A2 pistons in a K24 block gives you 11.5.1. Need lower compression for boost? K24 pistons in everything drops it to 9.8.1. Want better cams? The K20A Type R cams drop right in. Need more displacement? Bore it to 87 mm, stroke it to 102 mm. Now you have 2.6 liters. Every combination had been tested, documented, proven. The community created spreadsheets calculating every possible configuration. The swap potential was unlike anything before. The K-Series was physically smaller than a B-Series despite the extra displacement. It was lighter than an F-Series. It made more power than an H-Series. The engine mounts were simple. The wiring was straightforward. People started putting them in everything. Classic Civics, CRXs, Miatas, MR2s, Lotus Elises, sandrails, go-karts. If it had an engine bay, someone figured out how to stuff a K-Series in it. The racing world took notice immediately. In time attack, K-powered cars started destroying lap records. The power-to-weight ratio was unmatched. In drag racing, K-Series cars were running 8-second quarter miles with stock blocks. In Formula D drifting, drivers loved the instant throttle response and linear power delivery. Even in endurance racing, the K's reliability meant you could run 24 hours at full throttle with just basic maintenance. Honda's manufacturing precision played a massive role. Tolerances were held to 0.001 inches on critical dimensions. The cylinder bores were plateau-honed for optimal ring seal. The deck surface was so flat you could check it with a precision straight edge, and not fine deviation. Main bearing clearances were controlled to 0.005 of an inch. This wasn't just good for a production engine, this was race engine precision at mass production scale. Think about that for a second. Every single K-Series engine, whether from an Accord, a Civic Si, or a CR-V, was built to the same exacting standards. Honda produced millions of them. Millions of potential race engines sitting in junkyards for $400. Complete swap packages for under $2,000. That's less than a built head for most platforms. The aluminum block design that everyone worried about being weak? The deep skirt design and extensive webbing made it stronger than most iron blocks. The open deck design that should have been a limitation? Builders developed block. Guards and sleeve solutions that handled 40 psi of boost. The high compression that should have required race gas? The combustion chamber design was so efficient it ran on 87 octane if needed. By 2010, the K-Series had completely transformed Honda performance. The B-Series market collapsed. Why spend $8,000 building a B18 when a junkyard K24 made more power stock? D-Series builds became extinct. F-Series swaps disappeared. Even the mighty H22 couldn't compete. The K-Series didn't just win, it eliminated the competition entirely. Tuning shops that specialized in other platforms switched to K-Series or went out of business. Aftermarket companies rushed to develop K-Series parts, turbo kits, supercharger kits, individual throttle bodies, dry sump systems, billet blocks capable of 2,000 horsepower. The market exploded beyond anything the B-Series ever achieved. The factory continued development too. The K20C turbo in the current Civic Type R makes 306 horsepower from 2 liters with a warranty. The K20C2 in the Accord makes 252 horsepower with regular fuel. These aren't special engines. They're the evolution of the same basic design from 2001. But here's what really makes the K-Series overpowered. It's not just the strength. It's not just the power potential. It's not just the modularity or the swap compatibility. It's that Honda accidentally created the perfect enthusiast platform, an engine that rewards modification but doesn't require it, that runs forever stock but handles 500 horsepower without complaint, that fits in anything but came in everything, that's sophisticated enough for modern emissions but simple enough for garage builds. 23 years later, nothing has matched it. The Toyota GR Corolla engine is impressive but complex and unproven. The Ford EcoBoost makes power, but lacks the aftermarket. The Hyundai Theta is strong, but thirsty. Even Mazda's Skyactiv X, with its compression ignition technology, can't match the K's combination of power, efficiency, and modification potential. So, what was actually going wrong with every other engine? Why couldn't anyone else build something like the K-Series? The answer is intention. Other manufacturers built performance engines or economy engines. Honda built an economy engine like a race engine. They applied the same development process they used for Formula One to a Civic motor. They tested components way beyond their intended use. They overbuilt everything because the cost difference between adequate and exceptional was pennies at production volume. A connecting rod that can handle 300 horsepower costs maybe $20 to manufacture. One that handles 600 costs $25. At millions of units, Honda chose the $25 rod. The same philosophy applied to every component: pistons, valves, valve springs. Even head bolts were upgraded beyond necessity. The result was an engine that had Formula One DNA in a grocery getter package. The modern K-Series scene is even more insane. Builders are making $2,000 horsepower from 2.7-liter destroked K-Series builds. That's 740 horsepower per liter from an engine platform designed for an Accord. The fastest front-wheel drive car in history uses a K-Series. The quickest all-motor import drag car uses a K-Series. The most powerful naturally aspirated four-cylinder ever dynoed is a K-Series making 518 wheel horsepower on pump gas. Here's something that'll blow your mind. The K24 in a 2008 Honda CR-V makes 166 horsepower stock, with intake, header, exhaust, and a tune, maybe $1,500 in parts. It makes 210 wheel horsepower. Add a supercharger kit for $4,000 and you're at 350 wheel horsepower. Upgrade the clutch, add methanol injection, and you're pushing 450. All while daily driving to work in traffic. Try that with any other platform. The transmission strength meant you didn't need expensive dogbox racing transmissions. The ECU flexibility meant you didn't need standalone engine management. The factory sensors and wiring were good enough for 1,000 horsepower. Even the alternator and starter could handle the demands of high horsepower builds. Everything was overbuilt, but the real story wasn't just the specifications, it was the democratization of speed. Before the K-Series, building a fast Honda meant deep pockets or deep knowledge, usually both. B-Series builds required careful selection of parts, machine work, custom tuning. One wrong combination, and you had an expensive paperweight. The K-Series changed that. Any kid with YouTube and basic tools could build a 400 horsepower K-Series. The recipes were proven, the parts were available, the knowledge was free. This accessibility transformed car culture. Time Attack went from exotic builds to K-swapped everything. Drag strips filled with K-powered hatches running 10s. Track days became seas of K-swapped Miatas, embarrassing Porsches. The engine became so dominant that some racing series specifically banned it to maintain competition. The physical design enabled things Honda never intended. The intake manifold was on the front, perfect for rear-wheel drive swaps. The oil pan was shallow enough for mid-engine applications. The accessories were modular and could be relocated or deleted. The water pump was integrated into the block, eliminating external plumbing. Every design choice intended for packaging efficiency accidentally made it the perfect swap candidate. Even today, with turbocharged engines dominating from factory, the K-Series remains relevant. The new CTR's K20C makes 329 horsepower with a tune alone, no hardware changes, just software. The aftermarket has pushed these Turbo K engines past 600 wheel horsepower on stock internals. The platform that started in 2001 continues evolving, continues dominating, continues surprising. The prices tell the story. Clean K20A2 engines from RSX Type S models sell for more than they cost new. K24A2 from TSXs command premium prices. Even high-mileage K24s from CR-Vs sell instantly. The demand has never decreased. If anything, it's stronger now as people realize what Honda created. But here's the philosophical angle that matters. The K-Series represents something bigger than just an engine. It represents what happens when engineers are allowed to over-engineer. When accountants don't compromise quality for quarterly earnings. When a company's racing heritage influences its economy cars. Honda didn't set out to create the ultimate four-cylinder platform. They set out to build a reliable, efficient, emissions-compliant engine for mainstream vehicles. By refusing to compromise on engineering excellence, they accidentally created a masterpiece. Today's manufacturers could learn from this. Instead of building dedicated performance engines that few can afford, build every engine like it matters. Use forged internals even if cast would suffice. Design for modification even if most stay stock. Create modularity even if it costs more initially. The K-Series proved that exceptional engineering at volume creates its own market. The K-Series killed Honda's other engines not through corporate mandate, but through superiority. It became overpowered not through intention, but through over-engineering. It dominated not through marketing, but through capability. 23 years later, it remains the standard by which all four cylinders are measured. And honestly, nothing else comes close. What's the most impressive K-Series build you've seen? Drop a comment below. And if you want more deep dives into legendary engines that changed the game, hit that subscribe button. I'll catch you on the next one.